they tell yourself in third person?
I love that. So what am I looking for when I see this problem here? What am I looking for on the unit circle?
The 45 degrees.
45 degrees, right? 45 degrees. Does everybody see that on the unit circle? Yeah. Which quadrant is it in?
1.
Does everybody know what quadrant is quadrant 1?
Top right.
Top right. And then the top left is quadrant 2. And the bottom right is quadrant 4. Good, I was trying to trip you guys up. So we're going to look in the first quadrant, and that's where 45 is going to be. So there is right here you're going to see 45 degrees. It's also going to have its radian equivalent, which is what for 45 degrees?
Pi 4.
Pi over 4. So you'll see that listed there as well. And then what's the point? What's the coordinate at 45 degrees?
Square root of 2 over 2, comma, square root of 2 over 2.
Square root of 2 over 2, comma, square root of 2 over 2. Now, William, you asked me at the beginning of class, you said, can I write down that cosine is equal to x and sine is equal to y, tangent is equal to y over x? And I said no, right? Because I want you to know that. If we know that cosine of an angle is equal to the x coordinate at that angle, then what is the simple answer to cosine of 45 degrees?
Square root of 2 over 2.
It's just my x coordinate right here, right? It's just square root
You
of
could
2
write the
over
y
2.
coordinate and you get it right.
Technically, I was right. Okay. You were both of them.
Do you guys see how easy that is? When you have the unit circle, how simple that is?
Literally.
You just find the angle and you pick the x coordinate if you're finding the cosine.
Now he's going to give us another problem, take away our unit circle.
Now, what if I'm doing the next one? Is the next one sine of pi over 3?
Yeah, it's a sine of pi over 3.
Sine of pi over 3. Now I'm dealing in degrees or radians?
Radian.
Radians. The sine is which coordinate? No.
It's the y.
Cosine is x. Sine is y. Think about them in alphabetical order. C comes before s, cosine before sine, x comes before y, right? So maybe that'll help you remember.
We
What's
can,
that?
You weren't in the shot.
Sorry, James. Class, say hello, James.
Hello, James.
Sorry you're not feeling well, James. And maybe we should say hello to Noel. I don't know what's going on with Noel, but hello, Noel.
Hello, Noel.
Sorry you're not with us. I don't know what's going on, right? I didn't say sorry you're no longer with us. I just said sorry you're not with us today.
I know.
So let's think about this one. So I'm looking on my unit circle. I'm going to remove this line because I want to zero in on the one that matters for this one, right? So I'm looking for pi over 3 on my unit circle. Which quadrant is that in?
Quadrant 1.
It's also in quadrant 1, right? So it's up here. How does it, let me see how it looks on your unit circle, just to make sure I'm drawing it.
It's above it's right here.
Yeah, so it says 60 degrees right here, and it says pi over 3 right here, to signify that that line is for both of those measurements, because 60 degrees is equal to, 60 in degrees is equal to pi over 3 in radians, all right? And so I'm looking at this point. What is my point right here at pi over 3?
1/2.
1/2?
Square root of 3 over 2.
And square root of 3 over 2. So I'm trying to find the sine. I'm finding which coordinate, Megan?
X.
Sine
Sine
is the
y.
y coordinate, right? Alphabetical order. And so this has got to be square root of 3 over 2 because that's my y coordinate right there.
Sine equals pi over 3, which equals square root of 3 over 2. Okay, I can see that.
You guys see how easy that is? I mean, you didn't have to do any calculations. You just looked at the unit circle and said, that's the sine of pi over 3. That's the y
Can I
coordinate.
just put this
For
as
the
my answer?
tangent, I hadn't switched. I did x over y. So when I got the thing, there was a
So for your tangent one, the next one?
yes.
Come on, okay.
I figured it
We
out
shall
before
see.
it was done.
All right.
Chelsea, bud.
So these are the simplest versions of these problems I could give you, right? If I give it to you in quadrant 1, super simple. You're finding that exact degree measurement. It's really easy. But actually, on here, they, because of the way that they go on around the unit circle, the next one's pretty easy too. So what was the last one?
Use a reference angle to find the sine, cosine, and tangent of 120 degrees. Find exact values.
So sine of 20 degrees, cosine
120
of
degrees.
120 degrees, sine of 120 degrees, tangent of 120 degrees. Now, where is that on my unit circle? Quadrant
2.
2, right? This one's actually easier than they even told you that what you needed to do in the problem, because I gave you your unit circle. They said find the reference angle. So if we had found the reference angle, what does that mean? When we say the reference angle. So this whole thing here,
The reference angle is
Oh,
the
is that the
closest
thing where you
distance
made
to
us
the
count last
x-axis.
week?
this is 120 degrees, or what is it in radians?
2 pi over 3.
2 pi over 3. Good. And what's my point right here?
Negative 1/2 square root of 3 over 2.
Square root of 3 over 2. So the reference angle is the distance from this line to the x-axis, right? Whatever quadrant it's in. So what is the distance from that line to the x-axis?
40. Wait, 60.
What'd you say? 60, right? Because this, all the way to this line is 180 degrees,
Oh.
right? If I go from here all the way there is 180, I back up to the 120, that's 60 degrees. So this reference angle is 60 degrees. And so when the problem says use the reference angle, they're saying, they're like, what if you only had the first quadrant stuff? And so with the first quadrant stuff, you had that 60 degrees has a coordinate of 1/2 and square root of 3 over 2, right? So I can use these numbers here, since that's my reference angle. I just have to make sure I put the correct sign on them because I know my angle is over here, right? So that's what the reference angle does for you. The numbers will be the same, it's just the signs will vary depending on which quadrant that you're in. But since your unit circle already had that on there, I didn't even need to do the reference angle. I just look at where 120 degrees is, right? So I don't care about any of this stuff actually. And I just do the same thing we did before. Cosine is which coordinate, Megan?
It's x.
It's the x coordinate, good. So this is negative 1/2. Sine is y, so that's square root of 3 over 2. And then what is the what's the tangent when you're looking at y and x? How do you figure out the tangent? Cosine is x, tangent, sine is y, tangent is.
I don't know.
Help him out, Jonah.
I know
Okay.
it. It's tan and sin divided by cos, right?
Sin divided by cosine. Okay, sine divided by cosine. And since sine corresponds to which coordinate?
Sine, that would be the second one.
The second one. So y. So sine is y, cosine is x. So that means tangent is y over x. Okay? So tangent is y over x. So that means we take our y coordinate, square root of 3 over 2, divided by our x coordinate, which is negative 1/2, right? So the hardest, this was definitely the hardest one because you're gonna have to do a little bit of multiplication, right? You're gonna have to know that when you divide by a fraction, that's the same as doing what?
Multiplying.
Multiplying by the reciprocal. Some teachers teach it.
Keep change flip.
What does they tell me is my other class? They say it's keep, change, flip. That's
Yeah.
right. Keep, change, flip. And that means you keep the
keep the
numerator
first
the same,
Change the sign, flip the other part.
change the sign from division to multiplication. Is that
Yeah.
what it means? And
Yeah.
then you flip the denominator.
I've never.
I just think multiply by the reciprocal of the denominator. That's what I think of. So it's square root of 3 over 2. The reciprocal of negative 1/2 is negative 2 over 1, right? So when I multiply, my 2's are going to cancel out, and I'm going to be left with just the negative square root of 3. So that was the answer for the tangent of 120 degrees. Do you guys see how easy that is? I mean, literally, if you knew what you were doing with the unit circle, you could have had this probably done in 2 minutes max, right? It's really simple and easy once you understand how the unit circle works. Yeah.
Can you cancel them out though? Because that's a negative 2 and that's a positive.
Well, that's why the negative stayed there. So,
Oh.
right? I mean, if we didn't do the canceling there, we would have gotten this. We would have gotten negative 2 square root of 3 over 2.
Would that still count?
And the 2's would have canceled out here, so you negative square root of 3. All right. So they still cancel out. All right. Questions? You see why you didn't need your calculator? Right? The unit circle had everything for you. You didn't really have, this was as complicated as the math got right here.
Multiplying fractions.
Yeah. And really simple fractions too. All right. I hope you guys took good notes on the quiz because expect to see a problem like that again on the test, right? And I want you guys all to ace those problems when you see them. You have a question?
Are there going to be some that you have to do like calculations on? Because in the lesson, there was a couple that were a little more in depth that were pretty difficult for me.
Where you have to use your calculator?
Yeah.
Yeah, yes, definitely. I just, this one, and because I told you guys that last week, I wanted to give you a unit circle and I wanted to check your understanding of the unit circle. Other students, when they get in my pre-calc class, they are confused about the unit circle because they've never seen it before. So I just want to make sure that you guys understand really how simple a concept it is once you recognize how it works, right? Yep.
Will we be taking this test over the break, or will we be studying over the break and taking it anytime?
That is a good question.
Also, can we use our unit circle on the test?
Yes, you can.
Yes!
All right. Let me see, when did we take the last test?
Not a clue.
A lot.
Has it been a while? Was that what we took at the end of the year?
Yeah.
It's been a minute.
Okay.
Right before.
So, so our last test covered, let me see. Sorry for those of you watching the video, this is the boring part. Nothing exciting to see right now. It looks like your last test went through lesson 51, and we're doing lesson 64. So, ooh, yeah, we're pretty close to coming up on a test. So probably will be, oh, but then we've got winter break, right? So is winter break 2 weeks from today?
Winter break's after.
Next week, we don't come back next week.
Winter break is next week?
I'm pretty sure.
After
Yes,
today,
sir.
we don't go to class next
Is
week.
it?
No,
Yes,
we're-
sir.
Seriously? Well, I was
Why didn't nobody
excited,
inform me of this?
I didn't know.
but I'm not excited because it's not lining up with my other schools. So I'm only getting Thursday off. So why don't we plan on? We've really covered enough chapters for us to do the test. Let me go over what I'm going to go over today, and I think I will probably have you guys. I don't want to come back after the break and have to take the test. So we'll plan for it the week. I guess the end of the month. I guess the last Thursday of the month is probably when the test will be.
In class, we're gonna hand it to us.
You know what? I probably will have you take this test at home. So actually plan for me to hand out the test when we come back from the break. All right? Sound good? Are you good? Were you sending up praises?
Thanks, Emil, praise the
Okay, all right, excellent. So test to go home with you 2 weeks after today. All right, let's talk about another question? Did I hear something? No? Someone
No, we
just-
said yay.
Okay, all right. Let's talk about logarithms.
Wait, we went over this with Miss Craycraft. Are we doing a new lesson?
Oh, that's right, Ms. Craycraft did. I'm sorry, I forgot we had to back up. We're not talking about logarithms. Are you guys good with logarithms?
Yeah.
You understand it?
I mean, I'm good with the more complex stuff.
I
It can be played.
You need to recognize this. If I say log of 2a equals x, and you want to find what x is, you need to realize that the problem you're doing is this 2, this base, raised to what power gives you 8. So what is log base 2 of 8 going to be? It's going to be 3, right?
There's a formula to find
Because
that
2 to the third power equals 8. All
Isn't
right?
there a formula where you can find out what x is? I'm pretty sure there is.
Well,
I don't
I'm going
think
to
we've
show
done
you
that
guys how
yet.
to use your calculator to do that. But you guys didn't talk about change of base formula yet, right?
No.
Yeah, so what that's coming. So you'll be able to check your work. Right, and she also went over the quadratic formula with you guys, correct?
She did.
All right, good. So let's go to chapter 66 then, solving polynomial equations. All right, and this is a really, I know you get sick of hearing me say this, but I am purposely selecting chapters. Like if we ever skip a chapter, it's very unlikely they're going to see that again. I'm specifically trying to focus on chapters that are going to come up again, and this is just a really important concept here. Being
We're
able
halfway
to
through the book.
solve polynomial equations.
Because we're barely halfway through the book.
Yeah, we're on 66. I mean, we're not going to be able to get through all 120 lessons.
Wait, because you gave us the answers, we won't return these quizzes, right?
No, you will not. Oh, I got to check your homework. You just put it away.
He said, did he check homework? I was like, I don't think so.
All right, I'm going to pause this. Okay, yeah, it looks like it's still continuing the previous video. So, lesson 66, solving polynomial equations. Let's do the first example. Alright, so normally, when we talk about solving polynomial equations, if I give you a polynomial equation like this,
Don't trust me now. I'm just
alright, and I tell you to solve that polynomial equation, how would you tackle this?
Foil or factor.
The reverse of FOIL, right, which we call factoring, right?
Right.
So we would factor this into two binomials, and you know we're looking for, so we got x in the front here, and we're looking for values on this side that when multiplied together give us -18, but when added together give us -3. And so what are we going to have here and here? Braden?
3 and 6.
3 and 6.
Negative 6.
So -6, good, and a +3, right? Because -6 times 3 is -18, but -6 plus 3 is -3. So that's how we know we factored it correctly, right? So you should be getting good at that. That's something that you should have been doing for at least a couple of years now. I don't know that we did it much in algebra, geometry, probably didn't refresh on that much, but you should have seen it in Algebra 1. But you need to get better and better at that, because this is one of those things that doesn't go away, right? I told you got to get good at it. If you take any other math courses beyond here, whether in high school or in college, you're going to encounter this again, all right? So factoring polynomials, important. But now that we see a polynomial like this, at first glance I look at that and I'm like, I have no idea what to do, because I'm used to seeing x squared, right, being the highest number, and now I've got something which is x to the 4th power. So we're going to start discussing some tricks that we can try to help us factor something like this, even though at first glance it looks like I don't have a good way of doing this, right? I don't really know how to do it. Now, when we've got these kind of equations, sometimes these equations are hard to solve, and it doesn't factor as easily as this one did here. And so what have you guys learned that will help you factor a second degree polynomial like this when it's not easy to factor?
The quadratic equation.
The quadratic equation. I was trying to be careful not to say a quadratic equation so that it wouldn't give away the answer. So the quadratic, did they call it the quadratic equation or the quadratic formula?
Isn't it?
Quadratic formula, because this is a quadratic equation, all right? So the quadratic formula is how we can always find out what these x's would be if it's not easy to factor. By the way, if I said solve for x here, we're not done, right? What else do we have to do to solve for x in this problem, Katie?
You would do like x minus 6 equals 0 and solve for x.
Yep, x minus 6 equals 0, that means x equals 6, and then I also have to do x plus 3 equals 0 and solve for x and get x is -3. So that would be our two solutions for x in this problem, right? We want to do the same thing over here now. So what can we do, what kind of tricks can we try that will help us get something that's more familiar to us? And so Elias sees it. Does anybody else see? Caleb, do you see anything that we could maybe try?
Factor out a 2.
Okay, so we could factor out a 2. So he sees that every term has a 2 in it. And so that's kind of our first trick. We're going to look at it and say, is there something that's common to every term that's in here? So 2 is common to every term that's in here. Is there anything else?
X squared.
X squared. You guys see that? So every term has a 2 in it. It's divisible by 2. Every term is also divisible by x squared. So we're going to pull out both of those. And we're going to say 2x squared. And so what are we going to be left with? Well, 2x squared times x squared gives us 2x to the 4th, right? 2x squared times -5x gives us 10x cubed. And then 2x squared times -36, is that right? Gives us 72, -72x squared. Does everybody see where I got those numbers? Okay,
Yes, sir.
so I just factored that out, and I have to set it equal to 0. Now again, the goal here is to solve, the goal here is to solve for x. So we got to do the same thing that we did over here when we were solving for x. That's eventually what we want to get to. But look at what happened when we factored out the 2x squared. What's left right here? It's a simple quadratic equation which we're familiar with, right? So we're going to factor this guy just like we've done before. And let me see who I want to call on to help me do that. We know x is going to be right here in the front. Let me make sure I know what the answer is. I see it. Okay. So Seth, can you help me by telling me what two numbers, when multiplied together, will give me negative 36, but when added together, give me negative 5?
4 and 9.
4 and 9. Which one's got to be negative? One of those has to be negative. When we add them together, we want the sign to be negative. So the bigger of the two's got to be negative, right? So we want a negative 9, and we want a positive 4. You guys see that? Negative 9 times 4 is negative 36. Negative 9 plus 4 is negative 5. So now we've factored that. We set it equal to 0 again, and so now we're going to do the same thing that we did before. We got to take everything that's multiplied together here and set each of those individual pieces equal to 0. Why is that? Do you guys understand why we do that? Why do we say 2x squared equals 0, x minus 9 equals 0, and x plus 4 equals 0? Why do we say that?
Because if we were to graph that line, that's how many times it would cross the x-axis.
Okay, that is, what we're eventually finding are the places where it crosses the x-axis. That's true, but just from a simple mathematical standpoint, why do we say either this can be 0, this can be 0, or this can be 0, Alex? Why would we say that? Because if I have A times B times C equals 0, what do I know about A, B, and C?
One of them's got to be 0.
One of them's got to be 0, right? The only way I'm going to get 0 for the answer when they're all multiplied together is if one of those guys is 0, right? So what we say here is, here's my A, here's my B, here's my C, right? I've got 3 things multiplied together. One of those things has to be 0 in order to get 0 for the answer. So that's why we do this. So what does this simplify to? 2x squared equals 0. What is x? X has to be 0, right? You could either just look at it obviously and say, yes, x got to be 0, or there's no way I could get 0 there. Or you could do your normal algebraic operations and say divide both sides by 2, x squared equals 0, take the square root of both sides, so x equals the square root of 0, which is 0. Either way, you're going to come up with x equals 0. This one is x equals 9, and this one is x equals negative 4. So that would be, I'd have 3 answers this time for x. Questions?
I didn't understand what to do. I just don't understand the meaning of finding 0 with each one.
Why we're finding these? Well, this one here is just like any other equation where they give us an equation and they say solve for the unknown. So x is our unknown value in this, and we just want to know what are valid values for x that would make this equation true. All right. So if I plugged in a 0 for x, or a 9 for x, or a negative 4 for x in our original equation, those would be valid values. We'd get a true statement. Like this whole side would become 0 if I plugged in either of these values here. So we're just trying to find out what are the valid values for x that would give us a true statement. Make sense?
Yes, sir.
Now, if I wanted to know what the graph of this thing looks like, as Elias pointed out, this also means that my graph is going to cross the x-axis at x equals 0. It's going to cross it again at x equals 9, and it's going to cross it again at x equals negative 4. So it also means there are going to be points on the graph of this that where it crosses the x-axis. And I don't know if we're going to learn this in here. Definitely, if you take pre-calculus, we're going to learn like what this basically looks like. The way that we.
If you have a TI calculator,
Does it start this way?
Yeah.
Okay, so what we're going to learn in pre-calculus is that this thing's going to like come down like this, and it's just going to, no, actually it's going to go through that one. It's going to come through that one, and then it's going to come up and just touch that one, right? Is that right?
I think so. I mean, mine shot up to the ceiling, but that's because my window's too small.
It has a multiplicity of 2. But yeah, it's not working out the way that I thought it was gonna work out there. So this one's shot up right here?
It's shot like through the roof.
Okay. I'm thinking it's gonna do that there. But, which is cool, it's like a W, you know, for Mr. Walker. Just the perfect one for me to do in class. But that may not be right. I don't, it's been a while since I've taught this in pre-calc, so I don't remember specifically the rules. But I do, if I'm not mistaken, this one here, because we had to take the square root of this, it meant that technically it could be plus or minus the square root of 0, so it would be plus or minus 0, so there are 2 possible answers there, and I don't know. I may be thinking about that incorrectly.
When I have a window of 100, it is still out of my
Yes.
zone.
I was wondering,
Yeah.
I thought it only went through one of those points, cause there was only one answer to X. So-
No, there are 3 answers to X.
But all 3 answers, I thought X was the same for all of those.
Because think about how you plug this in your graphing calculator. If you plug this in the graphing calculator, you're thinking about it like that, right? Y equals that.
Yeah.
And do you see that every time we plug in one of these values, we're gonna get 0 on this side? So for each of these X values, what's Y going to be?
0.
Y is gonna be 0. So that means for an X coordinate of -4, my Y coordinate is gonna be 0. So that point's gotta be on there,
Yeah.
right? And for an X coordinate of 0, Y's gotta be 0, and for an X coordinate of 9, Y has to be 0.
So when I graph this and I have a window of 100, this is what it looks like. It just shoots straight up and down. I have a window of 100, and because I'm trying to see where it ends and curves back down,
Right.
and it doesn't.
Yeah. It's a crazy graph, so this is like kind of squished together, Elias is saying, and he has to make his window really big to see what's going on.
Yeah, the first Y value is 2,160. So
And I really, I don't want you to get too sidetracked by that, but that was just trying to answer your question, why are we doing this? One of the reasons is so that we can understand what the graph of this looks like, okay? What was your question?
Why did the line sag?
Why did it sag? So why did it go down and come back up?
Yeah, I was wondering.
So it has to do with the fact, it's kind of like when we graph parabolas, right? Like if I graph just this function right here, we've seen that that's always going to look like this, where it goes down like that, or it could open that way and go like that. So polynomial functions are always going to kind of have that part in it. They could just be a single sag, like you called it, right? Or it could be multiple that does like that, or it could have multiple that does like that. I mean, polynomials are always going to be like, and you could just kind of have more and more of those sagging areas and peak areas, the higher that this number gets right here.
So yeah, the
That's just the way
max Y
polynomial
value for
functions
this
look
one-
when you graph them. All right.
the max
But
Y
that's
value
kind of
is
beyond the
2,160.
beyond the discussion today. I was just trying to answer that very tough question. Why do I need to know this, or why are we doing this? You know, what's the importance? What's the reason?
What are the real life scenarios?
I can give you the simple scenario. Why are you having to learn this? For the glory of God. Because it's required of you as students, and you want to do everything that you do for the glory of God, which means submitting to the authority that's over you, and the authority is saying, you need to learn this. All right? So there's your simple answer. But some of you are going to go into careers where you're going to use this kind of math. So we're just trying to cover the
Can
basics.
you name a career that uses that kind of math?
It's
Engineering?
the engineering that I took, we went into this math and higher. So because I didn't actually work in that field and ended up going into computer programming, I don't know realistically how much I would have seen this in, because they did so much, I think, on computers, and the computers would do things for you. So how much of this math am I actually doing in my head now? I don't know, if I was an engineer.
Oh, okay.
Yes?
Alex wanted me to ask you. Do you have a certificate of did you have to go to school to learn how to teach, or did you just start teaching?
I'd started teaching.
Okay.
Yeah.
Does the
That's
government-
why I'm a tutor
Is the government
here versus a teacher. Because your teachers are officially your parents. So as a homeschooler, your parents can teach you, or you can have somebody tutor you that, you can have someone instruct you that has a bachelor's degree, which is what I have. Just so happens I had a whole lot of math in my bachelor's degree, so.
So
kinda helped
you're
prepare
not
me for this.
officially a teacher, but you're a tutor.
I'm officially a tutor.
Tutor sounds
Equals
smarter.
this. But I did a lot of tutoring when I was in college, and so that kind of, I didn't realize it was helping prepare me for this, but it was, right? So yeah, if you're like Mr. Walker's really a lame teacher, now you know why, right?
No,
I
he's
never
not
learned.
technically
I never learned how to do it, right? All right. So let's look at the next one, example 2, and let's talk about multiplicity. What does that mean? So x to the 5th plus 8x to the 4th plus 16x cubed. All right, so hopefully you see immediately the trick that we used last time.
I also see that one of them is going to be 0 because they all have an X in them.
They are, right? Okay. But, yeah, so then that's because we're factoring out at x, right? So the trick that we did last time is factor out what was common. Yep.
Maddie's question.
Yes. Factor out the any value that's common, and so what's common to each of these is x cubed. So we're left with x squared plus 8x plus 16 equals 0, right? And then we're going to factor this guy, and when we factor it, we get x plus 4 times x plus 4 equals 0. Okay? You guys cool so far? So we could write that. We could think of this as then x cubed times x plus 4 squared equals 0. You guys see that? Since we have two x plus 4s. We could think of it that way. And if we think about it like this number right here is going to tell me what the multiplicity is of that particular root. Now, what do I mean when I say root? If I gave you this and I said find the roots of this equation, what do I mean?
You'd find the answer like we just did.
It's the same thing we just did. It'd just be the same thing as saying solve for x. The roots are the values of x that make this equation 0. Or the values of x, yeah, that will make the left side of this equation 0. All right? And so if I did that, just like I did before, I'm going to see that if x cubed equals 0, then x has to equal 0. And if x plus 4 equals 0, then x equals -4. And I would do the same thing for the other one, and I would see x equals -4. Now, it's very easy to see with this one that we got -4 twice, right? That's what we mean by multiplicity. It means when I factor this thing, I would get two values that are the same of x, all right? So we would say that the solution for this is x equals 0 and x equals -4. But then if it asked us further about the multiplicity, we'd say we've gotten to the -4 twice. So we would say the multiplicity of 2. And again, because this is x cubed right here, we would say it's a multiplicity of 3. All right, so that's what the multiplicity has to do with. How many times that factor shows up in there.
Wait, how does it show up 3 times the first one?
When you get the scenario where it's just going to be equal to 0, you just take whatever the power of x is.
Okay.
All right. But for these, it's really easy to see, right? And that's why I was saying if you write it like this, it just kind of manifests itself based on the power that's there. So does the multiplicity idea make sense to you guys?
Yes.
All right. Thank you, Landon. That was
That was a really loud yes.
That was a dominate. It was like yes, big
Yes.
time yes. Better than the unit circle?
Like,
Okay.
I really like this.
This makes sense. The
This
unit
does
circle
make
did
sense.
not.
All right. Let's move on to. Remind me again what time we're out of here.
12:25.
12:25. That's what I thought. We're running out of time.
We should push it back 5 minutes every week until we get out as soon as we get in.
Now, so that's multiplicity. There's also there are a couple of boxes at the bottom of page 470. We have the rational root theorem, and we have the irrational root theorem. The rational root theorem just says that if we organize a polynomial in such a way that it's in descending powers, descending order of the powers, all right, which is how we've learned to organize a polynomial anyway. So to give you an example, if I were to give you this equation here, so let's say I were to give you that equation there. Huh?
This is a different lesson or the same one?
This is the same lesson. And that's supposed to be executed, that 3's kind of thing. Let's say I gave you this, and I told you to identify all of the roots, the real roots of this equation. What do I mean by real roots?
They're not imaginary.
Not imaginary. We've learned about imaginary numbers, right? So sometimes when you factor these polynomials, you end up with an imaginary number. But if I want to know what the real roots are to this, if we organize the polynomial properly, there's a way for us to figure out which values are possible real roots for this equation. All right. And again, what I mean by roots, when you solve for x, it's the answers that you get, right? It's the places where it crosses the x-axis. That's another way to think about it, the x-intercepts. So the first thing that I need to do, if you just needed to factor this guy, what's the first step?
Moving everything to one side.
Move everything to one side and do what when you do that?
Set it equal to 0.
Yeah.
Set it equal to 0, and what else?
Write it
Flip the
in.
sign. Yeah, flip the sign.
What'd it say, flip the signs?
Write the polynomials in descending order.
Put them in descending order, right? So I do tend to want to always have my highest power monomial be positive. So what I'm going to actually do is move everything to this side. And I'm going to say 0 equals x cubed. When I move the 2x squared over, it becomes negative 2x squared. The negative 11x is already on that side, so it stays the same. And then when I move the 12 over, I get that right there. All right, so if we organize it like that, set it equal to 0 and put them in order like that, then here's the formula that we use to figure out what the possible roots are, real roots for this equation. If we think of this value, let's see. So if we think of the constant term, I'm going to rewrite it like this, because when we do it, we always put the 0 on the right side, right? That's our common practice. So think of this right here as, I'm going to choose a variable to represent our constant term, which is 12 in this one. And I'm going to, so the variable p is going to represent that. The variable q is going to represent our coefficient on our term with the highest power. So what's my coefficient on that term?
X to the third?
Yeah, it's 1, right? The coefficient is 1, so there's an understood 1 in front of this. So in this particular equation, p is 12, q is 1, all right? The possible real roots for this equation will be whatever p over q is. All of the factors of p over q. All right, so let me write it like this, actually. Factors of p over factors of q. All right, so what are my factors of p?
3, 4, 6,
Yeah.
2.
3 times 4 is a factor. 6 times 2 is a factor. 1 times 12 is a factor, right? So I'm going to put those in order. How do they do them? Yeah, from lowest to greatest. So 1 is a factor, 2 is a factor, 3 is a factor, we said 4 is a factor, 6 is a factor, 12 is a factor, right? Those are all of my possible factors for 12. You guys agree with that?
Yes, sir.
Now that 12 is positive, and so positive 1 times positive 12 will give us 12, but isn't it also true that negative 12 times negative 12 will give us a positive 12?
No.
It is.
No, negative 12 times negative 12.
Thank you. Yes, all right. Elias got me again. It's like that verse in James, if anybody doesn't mess up with his tongue, he's a perfect man. How does that read? I think it says maybe offend. It's more talking about sin. But negative 1 times negative 12 is positive 12. Correct? So we have to take the negatives into account. So what we do with these factors here as we list them out is we put a plus and minus in front of each of those guys. All right? Those factors over our factors of Q. What are the factors of Q?
1.
1. But again, we
And
have to say
negative
plus
1.
or minus 1. All right? So what are the possible real roots for this equation right here?
1.
Well, if the 1 goes away now, right? Because 1 over 1 is just 1. 2 over 1 is just 2. So we would say this. Sometimes the math's not as nice and you end up having fractions on some of these things when you simplify it.
That's a lot of roots.
It's a lot, right? This is a terrible example because 12 is such a large number. But all they're wanting to tell you, all they're wanting you to list is the possible roots, and those are the possible roots of this. So what it means is that the possible real roots is that some of these values, not all of them, but if there are any real roots to this equation, those real roots are one of these values here. All right? So if we were to actually solve this guy,
We'd get 3 roots.
we would get 3 because it's x cubed. And I'm just curious, like, did they tell us any values? Yeah, so they tell us that 1 is a root. All right? How could I verify that if I started testing these possible values, how could I test it and verify that it's a root?
Plug it in.
I could just plug it in, right? So let's start with positive 1. If I plug in a positive 1 here, I have 1 cubed minus 2 times 1 squared minus 11 times 1 plus 12 equals 0. So I get 1. 2 times 1 is negative 2. Negative 11 plus 12 equals 0. 1 minus 2 is negative 1. Negative 1 minus 11 is negative 12. Negative 12 plus 12 is 0. So sure enough, that is a root. Okay? Do you guys remember anything we've learned previously that also tells you whether or not something is a root?
Is it the synthetic division?
Synthetic division. Do you guys remember doing that? If it's a root, what will happen when we do synthetic division?
We'll end with a
The remainder will be 0, right? So let's try that. So I'm going to take this thing here, and I'm going to divide it by 1.
Don't you flip the sign?
You're right. I would have to flip the sign. So I need to. Well, no, actually, this is right. That's right. The reason why that's right is because if x equals 1, that meant that x minus 1 was a factor. Because x minus 1, when it's set equal to 0, gives you x equals 1.
Okay.
Okay? Does that make sense?
Yeah.
All right. So we're going to write down our coefficients. Let's refresh our memory on how to do this. 1, negative 2, negative 11, positive 12. And let's do synthetic division. The first step, remember, is just to bring this guy down. So we have a 1 here. 1 times 1 is 1. And then we add together the negative 2 and the positive 1. What does that give us, Brady?
Negative 1
Good, very good. Then what do we do, Brady?
times the 1 times the negative
1 times negative 1, so we get a negative 1 right here. Add together again, that gives us a negative 12. 1 times negative 12 gives us a negative 12. Sure enough, when we add together, our remainder is 0.
It's the same thing we just did.
So we're proving, but what's the benefit of doing synthetic division instead of just plugging it in?
It's quicker for harder
No,
problems.
not necessarily. Remember what synthetic division, when we were doing it before, I didn't typically say, divide,
You add
if x equals 1, divide it by that. I would say take this guy here and divide it I would say take this guy and divide it by x minus 1, right? I would say that, and then you guys would do synthetic division. Well, and what it means is if you get 0 for this, it means then that x minus 1 is a factor of this polynomial.
So then we can factor that out.
And we can figure out what the resulting polynomial is by what we have down here. Because if you remember, this means x squared minus x minus 12 is the polynomial that results from the answer that we got down here. And so that means that this thing here could be factored into x minus 1, since we found out that the 1 was a factor, x minus 1 times whatever answer we got when we did the division, so x squared minus x minus 12. All of that now equals 0. And so now that gives me the ability to factor it further and figure out what all the factors are in the problem. All right? Now, we're not doing this part yet. We're just saying what are the possible factors. But we wouldn't have even known where to start if we didn't have this formula right here. Right? This tells us which ones to start with. Start doing synthetic division.
Oh, okay.
Okay?
Now there's another theorem.
So,
Yes.
does the factors of P and Q, do those always come from just the first?
Yep.
The
P
last.
will always be from the last one, and Q will always be from the first one. That's why you need to put them in order. So you need to know which one's the first and the last.
And say factor Q was 2 and not just 1. You would have to divide all that out.
So let's say this number here is 2.
Mm-hmm.
That's right. Yeah. So let's just say, for example, it was that. How would that change this? Well, this is now 2, and so our possible factors, our possible roots are
1 over 2.
plus and minus 1/2, right? 1 over 2.
Okay.
Plus or minus 1, because 2 over 2 is 1, plus or minus 3/2, plus or minus 4 divided by 2 is 2, 6 divided by 2 is plus or minus 3, and then plus or minus 6.
Okay.
Make sense?
Yes, sir.
But isn't 1 also a factor of 2?
Oh, you're right. You're right. We have to do plus or minus 1 and plus or minus 2. So in addition to these here, we would also have, we've already got the 1 in there. We've already got the 2 in there. We've got the 3. So we're going to have to add to this plus or minus 4 and plus or minus 12
Okay.
to get all of them. Good catch. All right.
I got my note.
Cool.
And the week before.
Does that make sense, guys?
And then work whatever.
Now remember, the best way to get good at these, you got to work the problems. You got to do problems. It's not gonna, this is not gonna make sense until you start actually working the problems, trying it on your own, trying to figure out, looking at the solution if you make a mistake, and then working another problem, right? I assign certain problems to you. It's never a bad idea for you to do additional problems if you are struggling with a concept, right? Look for other problems that are like that and do those as well. That's how you're going to get good at this. The bottom box on 470 is simply saying this. If you take the factor of, if you're figuring out the factors, like using the quadratic equation, for example, and you get a factor like this that's in this form, if you get a factor that's in the form a plus b square root of c, so in other words, it's very possible when you're using the quadratic equation that you get something like 1 plus 2 square root of 2, something like that. You could get that as an answer. If this is a factor, then 1 minus 2 square root of 2, or if that's a root, this right here will also be a root as well. Do you guys remember what we call that when it's the same thing, but we flip the sign in the middle? We look. I think. Huh?
The inverse?
No. We looked at it as a way to rationalize denominators when they had a radical in it like that.
It's on the tip of my tongue. I just don't remember that.
So we would say, like, if we had 2 divided by 1 plus 2 square root of 2, and we wanted to get rid of that square root of 2 down there, we would have to multiply top and bottom by that. Anybody remember? It's called the conjugate.
I knew it started with a C.
So if this ends up being a root, its conjugate will also be a root. All right, and that's because if you remember with the quadratic equation, the part that gives us the square root actually has a plus or minus in front of it. Right, so it tells us that both of those are going to be factors. So just something to keep in mind. That'll be true if you had an imaginary root as well. You can sometimes get imaginary roots, and the conjugate will also.
How do you
always
graph something that has an imaginary root?
It doesn't show up on the graph.
Ah.
All right, let's let me see here. Let's look at lesson 67. And we're back to our unit circle.
Already?
Already. And this is just talking about inverse trig functions. And making sure that we understand what that means. This is actually a pretty simple concept too. You guys have your unit circles?
Yes, sir.
Okay. So let me ask you a question. If I told you that the cosine of theta equals 1/2, could you tell me what theta is?
Theta equals the inverse cosine of 1/2.
Tell me what theta is. Theta is the angle. What does theta have to be if the cosine of theta is 1/2? Cosine corresponds to which coordinate, Megan?
X.
X, okay. So you should be looking on your unit circle and looking for all the places that X is 1/2. Where is X 1/2?
60 degrees.
60 degrees, is that the only place?
30 degrees.
On the X value?
300.
No.
No.
300 degrees.
300 degrees, right? So 60 degrees or 300 degrees would be valid answers to that, right? And I would have to tell you there that we're going to limit. I would have to tell you that theta is between 0 and it's greater than or equal to 0 or less than 360 degrees, so that you can narrow it down to that. Because actually, if you think about it, since the unit circle just continues to go around and around, right? We could add 360 to this and say that theta could also be 420, right? Or we could subtract 360 from this, and it just goes on and on and on. If Landon's like, don't do it.
Don't.
Right, so I'd have to limit it so that you could give me the value. Well, this is what we just did. Really, was use the inverse function of cosine. All right, so the beginning of the chapter there says that if cosine of theta equals a, right? In our case, we said cosine of theta was 1/2. That means then that the cosine inverse of a equals theta. Okay?
Why do we use theta?
We always use Greek letters for angles, and so sometimes they use alpha, sometimes theta. Those are just traditionally in math books what they use for angle measurements. But you'll see
Like
different
theta.
Greek letters depending on how many angles you have in the problem.
This book just really likes theta.
Theta's the one you typically start with, yeah.
Even though theta is like the 6th or 7th letter.
So you'll see this button on your calculator, right? And you guys are wondering, well, how do I use that button? Now you know what it's useful for. If I gave you this value, if I said cosine of theta, like I did here, cosine of theta equals 1/2, and you want to find out what theta is, well, this, right, if this is true, then that means theta is equal to the cosine inverse of 1/2, and you could actually punch that in your calculator.
And get 60.
Yeah, you guys see that? If you punch in cosine inverse of 1/2, you should get 60 degrees on your calculator, if your mode is in degrees.
If not, you should get point something.
Whatever pi over 3 is.
It was like that.
A little over 1. Everybody get that? Okay?
Yeah.
So notice something, notice the limitation on your calculator. The calculator is not going to tell you all the possible solutions, right? It did not tell me that within this range here, it didn't give me the 300 degrees. It's only going to give me one solution. What it's basically going to give you is the reference angle. And then you're going to have to figure out the other solutions based on that. Okay? So this is true for all of our functions. We could say sine of theta equals A, then sine inverse of A equals theta, and then we can do the same thing for tangent. So that's how you use those keys on your calculator. All right? So in the book, they said, give me all of the values, the possible values of sine inverse of square root of 3 over 2. And give it to me in radians. So your calculator is not going to be much help here as far as getting an exact answer. Your unit circle is what's going to be best. So use your unit circle to figure out what, if this is true, then we're looking for where is this true? Where is sine of theta equal to square root of 3 over 2? In other words, where is the y coordinate square root of 3 over 2? Where is it, Caleb? In radians.
Pi over 3.
Pi over 3, and where else?
2 pi over 3.
2 pi over 3. You guys see that on your unit circle? The y coordinate is positive square root of 3 over 2 at those two places on your unit circle, right?
460 and 120 degrees.
Now, did I limit this and say only give it to me between 0? Did I say between 0 and 2 pi?
No.
I did not. All right, so if I did not say this, what's going to be the correct solution? Well, like we said before, this thing's going to repeat every 2 pi, or every 360 degrees, right? So this is what you're going to want to add to the solution when it's not limited like this. All right, you want to say it's pi over 3. So this is the short version, but the full version would be pi over 3 plus 2 pi times an integer n. Because as I keep going 2 pi around the unit circle, I'm going to hit that point again.
What happened to the other one?
Huh? I'm not done with it yet.
Okay.
All right, so I have to do that for pi over 3, and I have to do the same thing for 2 pi over 3. Add 2 pi n to it. Yes?
I'm sorry, you seem to be out of time.
I know, you need to give me one more minute, all right? I think you'll be all right. 2 pi is equal to what in degrees?
118.
No. 2 pi is all the way around the circle.
0
2 pi is all the way around, so 0, but
or 360.
360, right? So how would this change if I was giving it to you in degrees? This one would be 60 degrees, and this one would be 120 degrees. So how would my answer change if it's not in radians, but if it was in degrees?
We have to
2
write
pi
this.
would be 360.
Plus 360.
That's right. So theta would be equal to 60 degrees plus 360 n.
Would it be plus or minus 360?
It could be either one, because n can be a positive, it's an integer, so it can be positive or negative.
Okay.
All right? And 120 degrees plus 360 n. Does that make sense to you guys?
The n is just
Yeah.
like the plus. or
N
minus.
is just an integer. So n, if you remember what integers are, they're it goes from infinity that way, -3, -2, -1, 0, 1, 2, ... Okay?
They're the actual numbers that we like to use.
That's right.
All right, guys, that's it for today. You guys have a wonderful. Sorry that I went 1 minute over. I apologize if you're not able to get that one last chicken nugget down. You know, that's my bad. That's on me.
You know what? You're